Okay, cliffhangers. Don't you love those cliffhangers at the end? You know, I can make the videos go 15 minutes, and then we have to stop because I use YouTube to upload the videos, and YouTube will only let me do 15 minutes at a time. Okay, so now how are you going to know to do all this? You're going to know to do all this because that's what I'm teaching you right now. This guy right here, this was called a constraint, or is called a constraint. A constraint is any sort of physical situation to which you must adhere. Here, we have 200 feet of fencing. But then it said we really are concerned about the area. So we really focus the vast majority of our attention on the area. And so I got a function in terms of one variable that gave me the area. Here is a formula for the area. Then it turns out that this formula is a quadratic exponent of 2, quadratic parabola. Then that a value was -2, so my vertex will be a maximum, and that's what it said. Find the maximum. So to find the maximum, find the vertex. And that's going to give me the answer to my problem. Find that vertex. So that's what we're going to do. So I'm just going to write my problem down again. A equals -2 times L squared plus 200 times L. And again, if you don't like L's and W's, go with X's and Y's. I don't care. My vertex. And we'll just call it L. Really doesn't matter what you call it. L equals -b over 2a. And so 200 over 2 times -2. 200 over 4 for 50. And then what a will be, so right there, that L equals 50 is the length where the area will be a maximum. That's what L stood for. We had L's and W, lengths and widths. And so when I went to find this vertex, and it has an L in there, that coordinate of the vertex where I used an L, and again, if you don't like L's, call it X, it doesn't matter. That L is where the vertex will be a maximum. So L is the length where the vertex will be a maximum. Then the maximum area will be what I get when I take my formula for area, A equal -2L squared plus 200L. When I take my formula for area, that formula there gives you area. You give me a value of L, I will give you the area. Well, we have a value of L. And we're certainly going to ask the calculator for some help there. -2 times 50 squared gives me -5,000 plus 200 times 50, and I really should be able to do that in my head, but I won't trust my head. 10,000, and so that's 5,000. So the maximum area was 5,000. We were measuring in feet, so that'd be square feet. The length, we already have that. The length was L equal 50. And the last thing we need is the width, because it said find the length and width. So the width, and it's not on this page, but back over here, we had a formula for the width. The width was 200 minus 2L. So the width is 200 minus 2L. And so 200 minus 2 times 50, which that would be 100. And so there's my answers. The maximum area, 50 square feet. Length, that was 50 feet. And the width, 50 feet. If you're one of the people that really like to list their units. Math people are a little sloppy about listing units, but I know in your science classes they really want the units. And there's that problem. And the last problem, I'm not sure we'll get it done on this video, but we'll see. Next one's not going to be quite as hard because they give us the function. We just got to interpret all the pieces. So, last problem, and there's an A, B, C to this last problem. An athlete releases a shot put whose path is modeled by negative 0.4 x squared plus 2.1x plus 6.1, where g of x is the height of the shot in feet, and x is the shot put's horizontal distance in feet from where it was thrown. So let's use our calculator and get a real rough picture of what's going on here. So zoom in a little bit. I'm just going to put that function that they gave us in there. And so it was negative 0.04 x squared plus 2.1x plus 6.1. Now we're just going to start by hitting that standard window. Now it's not going to be the best window, but we're just going to start by hitting the standard window, zoom 6, see what we get. Okay, so here, really not the best window. So remember what they said this function represented. It represented a person throwing a shot put. Now think about it. I throw a shot put, it's going to go up and come down. We aren't seeing the come down part. And it also said that x was the distance, horizontal distance thrown. And so we don't need any negative x-axis, and we don't need any negative y-axis. That this is a shot put, and you can envision that the person is standing right at the origin, and then they're throwing the shot put, we'll call it forward, on the positive x-axis. So just trying to get a better picture to visualize what's going on. And it's a guess at this point. I'm going to press window, and I don't need any negative x. Now I want to see my axis, so I'll start -1. And I don't know how far people throw shot puts, so I don't know if people can throw shot puts 50 feet, but we'll try 50. And I'll count that off by 5s. We don't need any negative y values, so I'll go -1, just so I can see the axes. And I don't know how high shot puts go. Maybe they go 30 feet. I don't know. And let's count that off by 3. So we are sort of guessing here. I don't know how far shot puts go. Maybe they go as far as 50 feet. I don't know. Just a guess there. Decided to count that off by 5s. I don't know how high shot puts go, so I just put 30 in there. And let's see what we get for a graph. Okay, better. It's still not perfect, but we are getting there. We need to go a little bit higher and a little bit further. So going a little bit higher, so I'm going to press window again. We went, and we need to go a little bit further. 50 wasn't quite far enough, so how about we go to, say, 65? And that wasn't quite high enough. Let's say 45. Again, just guessing. And we graph that. And there is a pretty decent picture. And so that's what my shot put is doing. It's going up, coming down. The distance along the x-axis is how far it goes horizontally, and then the y-axis is how high it is. So there's a visualization of what's going on with this problem. Now that we kind of visualize what's going on, let's see what they actually want us to do with it. So zooming back out. Okay, what is the maximum height to the nearest tenth of a foot? How far from a point of release does this occur? So we already know that the picture looked something like that, all right? Just a real rough picture. That's what the picture somewhat looked like. So what is the maximum height to the nearest tenth of a foot of the shot put, and how far from the release, from its release point? Now the release point was right here. That's my release point that they talked about. The person was kind of standing at the origin, that's where they let go of it. The maximum height is going to be right there. At least the y coordinate. And then the part, how far from the release point that occurs, there would be the distance from release point. And so it's just really a matter of interpreting what they want. That the maximum height is this y coordinate over here. The distance from the release point is that x coordinate. And so what we have to do is find the vertex. And so one more time with that x equal negative b over 2a. And so negative 2.1 over 2 times negative 0.04 equals, and notice it says to the nearest tenth of a foot. And so it's actually telling us that we can use a calculator. So using a calculator to do that, negative 2.1 divided by, and that would be negative 0.08, gives us 26.25 feet, and that's the distance from the release point. Then my maximum height is going to be that y coordinate, so y of g of 26.25, and you're just going to put it into that function. And I don't really have room to write it all out, but I'm just plugging into that function. And when you do that, it comes out to be 33.6, and it says to the nearest tenth of a foot, so my calculator gives me 33.66 or 33.7 feet. And there's the first question, and then we can check this because we had the graph. So going back and looking at the graph, we said that it was about that vertex. We said that the x-coordinate, and we can still see it over here, that the x-coordinate was 26.25. So I'm going to do trace, and then put in 26.25, and we're going to hope it goes to that vertex. And then enter, and indeed it does go to the vertex, and so we are right. And if we zoom in a little bit, there we can see it a little better. It confirms my y-coordinate too, 33.66, which they said to the nearest tenth, so 33.77. So it absolutely does check. And that's where we'll end this video, and then we'll finish up this problem in the next one.